To all the students, I am Dr. Hima Bindu from the Department of Mechanical Engineering, Institute of Aeronautical Engineering, and I'll be dealing the robotics subject. And today we will discuss few problems on the axis rotation, right? So as you can see in the present question, we have a point P with an axis U, V and W with the coordinates U, V and W, where these particular axes have been given with the coordinates 4, 3 and 2 whole to power transverse. With respect to rotation, O, U, V, W coordinate systems, the corresponding points P, X, Y, Z with respect to the reference coordinate system, if it has been rotated about OZ axis, we need to give a solution. So how will we solve? In order to solve this particular problem, we need to first identify that the P, U, V, W is having a coordinates 4, 3 and 2 whole power transverse, right? Which is rotating in the coordinate system O, V, U and W at an axis of OZ, right? It is rotating at an axis of OZ. Now for this we need to first write down the rotational matrix. That is, we need to first write down the transformation matrix R. That is, R is nothing but cos theta minus sin theta and 0, sin theta, cos theta, 0 and 0, 0, 1. Right? So first we need to write down the transformation rotational matrix, which is R, which is given as a 3 by 3 matrix, which is cos theta minus sin theta 0, sin theta, cos theta 0, 0, 0 and 1. So further we need to convert these particular coordinates of U, V, W to X, Y and Z. Right? We need to convert the coordinates U, V, W to X, Y, Z in order to have a transformation matrix. So that we will be writing as R power T. Right? R power T is equal to cos theta sin theta 0 minus sin theta cos theta 0 and 0, 0. Now when we are applying this particular transformation to the system X, Y and Z, right? When we are applying this particular transformation to the coordinate points X, Y, Z system, we will be writing X, Y, Z is equal to transformation of the rotational matrix to that of U, V and W. U, V and W, right? So this we already have U, V, W values of as 4, 3 and 2, right? The rotation transformation matrix is this particular matrix which we will be inserting here, that is a 3 by 3 matrix. Now from this we will be finding out X, Y and Z, right? From this we will be finding out X, Y and Z. Now how will we find out X, Y and Z? X, Y and Z is equal to 4 cos theta plus 3 into sin theta. This one, 4 cos theta plus 3 into sin theta minus 4 sin theta plus 3 into cos theta, and the last one is 2. 2 into 0 is 0 plus 0 plus 2. So that is 2. Right? So from here we have got X, Y, Z coordinates. Right? That is X is equal to 4 cos theta plus 3 sin theta, Y is equal to minus 4 sin theta plus 3 cos theta, and Z is equal to 2. Right? Now this gives the transformation coordinates of the point after rotating the coordinate system about OZ by an angle of theta. Right? By an angle of theta, this is the angle. Now here if they are giving theta is equal to 30 degrees or theta is equal to 40 degrees, we will be substituting these values in this particular constant, that is 4 cos 30 plus 3 sin 30 or minus 4 sin 30 plus 3 cos 30 and 2. And we will be writing down the overall equation with respect to the angles. When the angle is, since the angle is not been given, we are just approximately taking the angle theta with an axis of OZ, and we have got x, y, z coordinate systems. Now, if the angle is being given, that is, if the OZ axis has been rotating at an angle of 30 or it is rotating at an angle of 40, then we will be substituting the theta value in the required equation, and we will be getting the overall final x, y, z value. Right? So this is how we solve this problem. Next, moving on to the second problem. The coordinate Q, U, V, W are having again 4, 3, 2, T. Now here what happened? We have got the angle theta at an angle of 45 degrees. So this particular angle 45 degrees we are converted into radius, that is theta is equal to pi by 4 radians. So cos 45 we know it is 1 by root 2 and sin 45 we know it is 1 by root 2. Right? Cos 45 is 1 by root 2 and sin 45 is 1 by root 2. And the rotational matrix we already know, the rotational matrix, that is the standard rotational matrix is 1 0 0 0, that is at an x-axis. Since this we have taken at a y-axis, z-axis, we have got this rotational matrix. Since this we are taking at x-axis, the rotational matrix will be 1 0 0 0 cos theta and minus sin theta, or 0 sin theta and cos theta. So here we will be substituting these values, right? Here we will be substituting these values, that is 45. What is cos 45? 1 by root 2. That we have written here for this matrix. That is rotational matrix is 1 0 0 0 1 by root 2 minus 1 by root 2 0 1 by root 2 and 1 by root 2. Right? As we already know, the coordinates x, y, z is equal to r of u, v and w. Right? So x, y, z is equal to r value, which is a 3 by 3 matrix, and u, v, w we already have, that is 4, 3 and 2. Right? So that when we are multiplying these particular two matrices, what we are getting, x, y, z is equal to root 3 by 2 minus 2 root 2, and sorry, this is 4 into 1 4 plus 0 plus 0, which we are getting as 4. That is the first quadrant, this 4. Next, root 3 by 2 minus 2 root 2 by 2. Right? This one. Root 3 by 2 minus 2 by root 2. The third one is root 3 by 2 plus 2 by root 2. Sorry, this is 3 by root 2, right? This is 3 by root 2 plus 2 root 2. That is the value of x. So what we are getting finally, x, y, z is equal to 4, 1 by root 2 and 5 by root 2. So when we need to simplify this particular coordinates, right? When we need to simplify this particular coordinates, we are writing 1 by root 2 as root 2 by 2. Right? When we need to simplify, we are writing 1 by root 2 as root 2 by 2. So that when we are taking with respect to y and z, what we have got, root 2 by 2 is for y, and for z it is 5 root 2 by 2. Right? The same for x, y, z, that is o, x, y, z are x is equal to 4, y is equal to root 2 by 2 and z is equal to 5 root 2 by 2. Right? So this is how we solve this particular problem when we have an angle and for the x direction. When we have considered for the z direction, it was different. The rotational matrix was different. When we are considering the rotational matrix for x-axis, the rotational matrix is different. Accordingly, we will be solving the problem. Okay. The next one is based upon the vector geometry. Right? Let me read the question. Determine the translation vector for the given vector v, which is equal to 25I plus 10J plus 20K, which performs a translation by a distance of 8 units, that is x is equal to 8 units, y is equal to 5 units, and z is equal to 0 units, right? For this, we need to solve the problem. Already the vector is being given as 25I plus 10J plus 2K, and XYZ values are given, that is 8, 5 and 0. The translation vector will be written as T is equal to, this is the translation vector which we write as 8I plus 5J plus 0K, right? The translation vector T we write it with respect to XYZ is 8I plus 5J plus 0K. So that when we are solving with the help of the translation vector, the translation vector formula is V is equal to V plus T. So when we are substituting that, we already have V, we already have T. So substitute the values here. What are we getting? 25I plus 10J plus 20K plus of 8I plus 5J plus 0K. So overall what we are getting? 33I plus 15J plus 20K. So this is how we find out we need to determine the translation vector. So this is how we have got a translation vector, that is V form, with the help of this formula, that is V plus T. What? So these are the differences which we have gone through. So in today's class, we have discussed about the one problem on the vector and the two problems on the rotational matrix with respect to the x-axis or with respect to the z-axis, or when we just consider theta angle, or when we consider theta as with some 30 degrees or 40 degrees angle, how we get the coordinates x, y, z. Clear? Hope you have understood. Do a practice session later. Then you'll have more understandability on these particular constraint problems. Okay. So this is all for today. Signing off for today, Dr. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.